Assalamu alaikum. Today, our topic is applications of binomial theorem. So we will try to understand some few examples, some examples, some applications of the binomial theorem. The first application is how to find the fractional part of some quantity. Now, before discussing this question, let's understand by the word fractional part of some quantity. The fractional part of any x is defined as, it is written like in curly brackets x, right? It is defined to be x minus greatest integer function of x. You know the greatest integer function of x, the students are aware about that. So let's take few examples to understand fractional part of x first. Say I want to calculate the fractional part of 1.1, right? So it would be 1.1, that is x, right, minus the greatest integer function of 1.1. So this is 1.1, right? Here 1.1 minus, now what is greatest integer function of 1.1? That is 1. Now you subtract the two quantities, so it is 0.1. So what is this 0. This 0.1 was the quantity which was actually exceeding this 1, the integer 1, right? So actually this 0.1 is the fractional value which was greater than 1. See here, if you look, if I locate, say this is here, this is 0, say this is 1, and say this is 2. So this is, suppose here it was 1.1. The integer values on both sides of 1.1 were 1 and 2, right? So this fractional value gives us 0.1 value. So it was actually the 0.1 quantity which was exceeding from the nearest integer, right? This one. Similarly, 1.9 would be 1.9 minus greatest integer function of 1.9. So this is 1.9 minus greatest integer function of 1.9 is 1. So this is 0.9, right? Now, this is these were the simple examples. Now we will understand this by the concept of binomial theorem. Suppose the question is, we want to find the fractional part of 3 raised power 2n divided by 8. Here n varies over natural numbers. It can take values, suppose 1. If n is 1, then it would be 3 by 8, fractional part of 3 by 8, right? Similarly, if n is 2, then it would be 3 raised power 9 by 8, and so on. Now this is the this is the graph. I have shown this, the graph of fractional part of x. Its values are always between 0 and here the top value is 1, and that is not attained, right? So it's like this one. This is the graph of fractional part of x, right? So no need here, but for students, if they want to remember this graph, then it is very beneficial for them. Now let's go to the question. Now this, I have to calculate 3 raised power 2n divided by 8, its fractional part. Now let's consider 3 raised power 2n first. It can be written as 3 raised power 2 into n. 3 raised power 2, you know, that is 9. 9 raised power n. And 9 can be written as 1 plus 8. This is good representation. You first put 1 and then 8, and right? Now why I have put first 1? Because in the binomial, now let's expand this by binomial expansion. You know how binomial expansion for two quantities x and y, x plus y raised power n. This is nc0, the first quantity, then x raised power the highest power, that is n, then y raised power the lowest, that is 0. That is why I have put here 1 first, because I have to put the highest power to it. So 1 raised power anything would be 1, right? Then next raised power 0, then go on decreasing the powers of 1 and increasing the powers of 8, we get this one, right? Now nc0, as already calculated in the previous lectures, this was 1. 1 raised power 1 is 1, anything raised power 0 is 1. So this whole quantity is actually 1. Now nc1, as already calculated, I would like nc0 is 1, nc1 is n. for all n, right? Now, so NC1, this is n, but I have written directly NC1. 1 raised power n minus 1 is 1. 8 raised power 1 is 8. Similarly, this is 1, NC2, 8 square, and so on. Now, what we do, we both sides divide by 8. So here divide by 8, and every term would be divided by 8. So this is 3 raised power 2n divided by 8, 1 by 8, then whole this thing. See here, if I divide here 8, 8 will cancel, divide here 8, 8 and 1, 8 in the numerator will cancel, and so on, because all of the terms from this to this, they are containing 8, right? Now, we are left with 1 by 8 plus this quantity. But what is this quantity? This is an integer. This is an integer quantity, right? So this is actually the fractional part, which is actually exceeding the integer, right? You see here, now 0.1 was actually the fractional part, which was increasing the nearest integer, that was 1 actually, right? So 1 by 8 is the fractional part, which was in which was exceeding the nearest integer. This is the nearest integer, right? So the fractional value of, therefore I will write the fractional value of 3 raised power 2n divided by 8 is equal to 1 by 8, right? Now let's move to another application of this one. See this one, divisibility tests. Now, when we say some quantity is divisible by some another quantity, right? So let's first go through the binomial expansion, the way that we have discussed, that is x plus y raised power n is equal to nc0 x, first raised power highest and then second raised power the lowest, right? Then go on decreasing the power of x and increase the power of y. So we will reach here. See, this is for any x and y. So suppose I will choose x to be 1 and y to be any number alpha. So this would be 1 plus alpha, because this is 1 and this is alpha. Now this is NC0, this is 1 raised power n, so it is 1. Anything raised power 0 is 1. So let's put it NC0 in simpler terms, right? NC1, 1 raised power n minus 1 would be 1, and alpha raised power 1 would be alpha, and so on, right? Now you know this is 1. Now let's put this in the similar terms, right? Now what we do is we transfer this one to this side, so this would be minus 1 is equal. Now see, from this term to this term, every term is containing alpha. Take out alpha common, right? Now up to this point, now let's go to some basic concepts. Suppose 6 can be written as 2 into 3. What we say that 6 is divisible by 2, right? So in real sense, I can write 6 is equal to 2 into some integer. Here in this case the integer was 3, right? So whenever 6 is written as 2 into some another integer, we say 6 is divisible by this 2, right? So similarly, suppose if I have quantity x is equal to 2 into some integer, suppose w, so we say x is divisible by this 2. Similarly, I can also say that x is divisible by w, because in that case 2 is the integer, right? Now similarly, in this case, see here, this is alpha into some another quantity, but this, that this is integer. It means that this quantity is divisible by alpha. So 1 plus alpha raised power n minus 1 is divisible by alpha, right? Now let's illustrate this within by an example. Suppose show that 9 raised power n plus 7 is divisible by 8 where n belongs to n. See here, we can use another methods also, like principle of mathematical induction to prove this example. But since we are here discussing binomial terms, so let's go by the binomial theorem. Now 9 raised power n, it is 9 raised power n plus 7, right? Now 9 can be written as 1 plus 8 raised power n plus 7 is there, right? Now expand this in terms of binomial expansion. This is x plus y raised power n. Here x is 1, y is 8, and n is there, right? So this is nc0, 1 raised power n. 1 raised power n is 1. 8 raised power 0 is anything raised power 0, that is 1. So this is NC0. Second would be NC1, 1 raised power n minus 1. 1 raised power n minus 1 is 1 into 8 raised power 1, that is 8. Right? And similarly, go on in decreasing the powers of 1 and increasing the powers of 8, we will reach up to this point. At plus 7 is there, and I have written it plus 7. NC0 is 1, as already discussed. Now this is 7 plus 1 is 8, right? So I have written here 8 and then rest of the terms, right? Here, from this to this, right? So this is 8, this is 8, this is 8 square, it contains 8, this is 8 raised power many 8s in multiplication. So let's factor out 8 common. So this is 8 into some integer. This is an integer. It means that this left hand side, that is 9 raised power n plus 7, this quantity is divisible by 8 for all n. For all n belongs to the natural number n. Suppose in terms of principle of mathematical induction, suppose we put some smaller values of n, say for n equal to 1, this would be 9 raised power 1 plus 7, this is 16, and 16 is divisible by 8. For n equal to 2, you can go and then put, suppose the result is true for n equal to k, and then we prove it for n equal to k plus 1. That can also be done in this in principle of mathematical right in that. But one more question is that there is one more application of this, that is how we can show some quantities are divisible by, say, alpha square or beta square and so on, right? Now let's stop here. Let's do that. Another application is in another lecture.